The curve has equation y equals g of x. Given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x. So that's making me think a cubic expression, so we need something x cubed plus something x squared plus something x, and so on. Now we're told that the coefficient of x cubed is equal to the coefficient of x. So I'm going to make both of those a. I don't know much about the b yet. Now, to begin with, I'm going to assume there is a plus c. But this next sentence here tells me that actually the curve passes through the origin, which is telling me that that plus c is going to be 0. We're then told we have a stationary point at the point 2, 9. So stationary point is telling me that the gradient is equal to 0 when x is 2. So I'm going to differentiate my function. So I would get dy by dx. Differentiating the ax cubed is 3ax squared. Differentiating the bx squared is 2bx. And differentiating the ax is just a. And I know that's going to equal 0 when x is 2. So when x is 2. So let's substitute 2 in there. The 3a times 2 squared, so 3a times 4 is 12a. The 2b times 2 is 4b plus the a. And then I can collect up these like terms to get 13a. Plus 4b equals 0. And there's not a huge amount more I can do with that at this stage, so I'm going to pause there. Now, I also know that the curve will pass through that stationary point, will pass through the point 2, 9. So I can substitute 2 in here, here, and here, and then substitute the 9 in here. So I will get 9 equals a times 2 cubed plus b times 2 squared plus a times 2. 2 cubed is 8. 2 squared is 4. Collect up these like terms. And I get 9 is equal to 10a plus 4b. I can now do simultaneous equations with these two equations to help me work out what a and b are. So let me do that. Let's copy that down over here. The first equation was 13a plus 4b. The second equation was 10a plus 4b equals 9. And if I subtract those from one another, that's going to cancel out, that's going to eliminate the b's. So 13a take away 10a is 3a. The 4b take away the 4b is 0. And the 0 take away the 9 is negative 9. Divide both sides by 3. And I've found that a has to be negative 3. Now, to work out the b, I'm going to substitute the a back into either of those original equations, either in here or here, it doesn't matter which. I'm going to do the first one. So 13 times minus 3 is minus 39, plus the 4b equals 0. So 4b is 39, so b is 39 over 4, just dividing both sides by 4 there. And I can now write down the equation of g of x, which is the a minus 3x cubed plus the b, which is 39 over 4, x squared, plus the ax. There we go, that's my answer for part A. Then for part B, we have to prove that the stationary point at 2, 9 is a maximum. So that's when the second derivative is negative. Sorry, that's what I need to show. The second derivative is negative at a maximum. So let's differentiate twice to get our second derivative. So differentiating the first time, the minus 3x cubed will differentiate to be minus 9x squared. The 39 over 4x squared will differentiate to be 39 over 2x. And the negative 3x will differentiate to be negative 3. Now we're going to differentiate for the second time. The minus 9x squared will differentiate to be minus 18x. The 39 over 2x will differentiate to be 39 over 2. And the negative 3 will cancel out. And so I can now say that when x equals 2, my second derivative is minus 18 times 2 plus 39 over 2, which is minus 33 over 2, which is negative, therefore a maximum.